This is what it looks like when we get the board. And then you come up with these two pieces. This is the power supply that drives a little relay and a little switch. This couldn't get any simpler than this. A little switch and an 8-foot cord mounts in the elevator pit. Here's the elevator shaft, right? And here's the elevator itself, cabled to a counterweight. Of course, this will work equally as well for a hydro as a traction. I've drawn a traction car here. But you got, Peter, you got a motor. Do you know what a counterweight is? Every elevator that has a cable-driven elevators, have a counterweight, so that the motor isn't actually picking up the weight of the elevator when it travels up. It's basically shifting the weight to the other side. This counterweight is 40% heavier than the car by design. They actually weigh the elevator itself empty and they say, okay, it's 3,000 pounds. This would be 3,000 pounds plus 40%, whatever that is. More like 4,800 pounds. That being said, you get some idea of what the counterweight, and this is what it looks like in the hatchway. The reason that's important, I'll show you in a minute. Now, on the bottom, underneath the elevator, and it's important that you know this, underneath the elevator gets its power from what we call a traveling cable. That's not such a good color, how about brown? It gets its voltage from a traveling cable. This traveling cable moves with the elevator. It's looped underneath it, and as the car travels up and down, this cable follows the elevator up and down. This is how it gets its electrical power. And that's really at the heart of why they want to get these elevators out of the pit, if the pit floods. Now generally, if this is the first landing, then you got, let's say, this is the first landing, this is the second landing, third landing, fourth landing, fifth landing, sixth landing. If the elevator is level with the first landing, the traveling cable is below it, is sitting in the elevator pit. This is considered the elevator pit. Okay? So now you get an elevator down, sitting at the first landing. Its cable is sitting in the pit. Well, these cables aren't waterproof. And if they were, they're not now, because they're wet. So what happens is, even though they're rubber coated, you don't ever want to submerge them in water. They're not designed to handle a lot of water. That coupled with the fact that below the elevator itself, on the elevator platform, is usually an interconnection box down here somewhere with all the interconnections, all the electrical connections for the whole elevator. And this cable is connected there to all of those connections. Well, if you get enough water in the pit, you can see where this interconnection box would end up below the water level. So now you're not only getting the cable, you're getting the interconnection box. That's the big thing. That interconnection box gets wet, you're done. Because it could short out all your safety circuits on the elevator and actually cause the car to travel.
It's called an interconnection box?
Yeah. Okay? So that's the thing we need to protect the most from getting wet, is that. That being said, what the liquid intrusion device does is, it comes in 3 parts. The first part sits at the very bottom of the pit, right down there. And at the bottom of the pit, it's got a little float switch. In its quiescent state, this way the circuit is opened, it's fine. If this float switch should float up to the top of the stop there, what happens is inside we trip a switch, close a circuit, and that circuit, which is connected to our small PC board, signals us that we have liquid in the pit. Or if you have a pit that usually has a little liquid in it, maybe you want to put it maybe 2 or 3 inches off the bottom. So that'll allow 3 inches of liquid before the switches. That's up to the installer. That's his job. It's designed. It comes in a little mounting box. box is not waterproof because it doesn't have to be. The switch is completely waterproof and oil resistant. So if you get oil in the pit, doesn't matter. Oil, water, whatever liquid it encounters, it will react to. This is a special switch that's designed to work in high temperature oil. Of course, we use it for other things, some of our other designs. So we decided to use this switch because we know it's a stable switch and it won't get damaged by water, oil, what have you. And basically it's on an 8-foot tether. There should be an 8-foot cord. Now once you mount the pit switch, you have to wire it to something. So above the pit, up here, you're going to mount the control board for the pit switch. The control board is simply comprised of a power supply, a 1/4 amp fuse. Now why a power supply? Why don't we run off full power from the controller? Because the code requires us to use low voltage, and they consider low voltage anything below 12 volts, or below 24 volts. So what we did was we created a board that uses a 12-volt power supply. The code also says it has to be fused at a 1/4 amp. The reason they want 12 volts and a 1/4 amp like this to exposed wiring is so that if you grab it or you're grounded and you touch something here, you won't get belted. There's no real current. And if it was grounded, a 1/4 amp fuse will blow way before you're affected physically by a short circuit. You're not electrocuted. So this whole thing was designed then to meet the industry standard. So now we have a power supply
That whole thing there is the power supply or just the yellow part?
Well, this whole board we consider the power supply for the switch. But yeah, it's basically this piggyback board. I'm going to send this around and let you look at it, but there's a piggyback board that's sitting on top of this. That's the actual power supply. But then we have added a fuse to it. We've added a relay to it. So what you do is you wire this to the board pretty much like that. This is in the pit. This is the control. Now, of course, this comes in its own little cabinet. And then what happens is, when the switch trips, the switch sends a signal here to the power board. The power board closes the circuit. Now, up here in the machine room, you have the elevator controller. That's the controller for the car. What you're going to do is you're going to wire this box. 4 wires go up to the elevator controller. That's 4 wires. Okay? 2 of the wires are going to power my power supply. The other 2 wires are going to be used to send a signal to the 3rd part of the system, which is the control board in the machine room, which is going to mount in the controller. And that's this little board. This little board mounts in the machine room. It gets its signal to operate from the control board in the pit. And what happens is this. First of all, we send power down to the board to heat up our little power supply and produce our little 12 volts that we need to monitor the switch position. And then what we're going to do is, when the switch trips, we're going to send a signal back into the machine room. So you have 2 wires supplying power, 2 wires going back for the signal. And once this board, which is mounted in the control system, in the machine room, receives that signal, it's going to cause the elevator to, based on how we wire it, and this is where we come in, depending on how we use the system, we're going to send the elevator away from the bottom landing. We don't want it here. We don't want to allow it to go there. If it's there, we want to get it out of there. So what we're going to do is we're going to cause the elevator to travel to some mid-floor, some place in the middle of the hatchway. Why not send it to the top?
Because we don't want the counterweight to be in the pit.
Good.
Oh, very good.
Good answer. We don't want the counterweight to end up in the water because counterweights traditionally have what they call compensation ropes, and counterweights sometimes have safeties on the bottom of them, and we basically don't want to be dipping our equipment in water. Not a good idea in this business. The other reason is counterweights have roller guides or slide guides that they ride on, just like the elevator has guides that it rides on. Well, we don't want those guides in the water because they'll rust, freeze up, and possibly rip out. Again, you don't want to cause any damage, so you want to keep everything out of the liquid. So the best thing to do, instead of sending it to the top, which would drive the counterweight to the pit, we send it to the middle. Now, in the middle, the car and counterweight are pretty much in the same plane, away from the liquid. And that's the object of the exercise, to get the counterweight and car away from the liquid. If the car is up here and the counterweight happens to be down here, doesn't matter. We still want to get the counterweight out of the liquid. So either way, we're going to send it to a mid-landing somewhere. We estimate that if we design the system, we design how this thing should be wired, the controller to create that condition of moving the elevator up out of the way, you're probably looking at about a 4-hour install. You're probably looking at an hour to mount the boards down here and wire them, maybe 3 hours to create this wiring, and maybe only another hour to wire this board into the control system so that it has the effect we're after. I designed this thing to provide two options. The first option is when we trip the switch and we send our signal up to the machine room to this board, once this board sees a water intrusion signal, this board will lock itself in place and will stay that way until someone goes to the machine room and physically resets the main line, which drops the relays out on this board and allows the system to go back into normal operation. That's one thing. But we designed this board with an option. Let's say that the mechanic, maybe he's got 10 cars. He's got these on all 10 cars. And he's saying, wow, if I trip all 10 cars with water, I have to walk to the machine room. That may not be palatable for him. So by moving a jumper on this board from the A position to the B position, that removes the automatic holding circuit. So that once the switch is reset, the elevator should go back into operation on its own without ever going to reset the system from the machine room. So we give them two options. There's a third option we can provide, and that's a reset from the pit switch, which is, every elevator has what they call a pit switch. It's a safety device in the pit, and it's basically an on-off switch for the elevator. We can also wire this board to operate off the pit switch, power, so that all you would have to do is flip the pit switch. After you reset your sensor here, and you've removed the liquid, you could just reset the pit switch, and that could reset this board, depending on how we hook it up. But he's always got this automatic reset option, if he chooses it. And we're going to leave that as an install option. So, and that's the only install option he gets.
The automatic reset option is done by moving the jumper?
Yeah.
Before you install it or after it's
Both.
installed?
It doesn't matter when you move it. In other words, we're going to ship it in the A position, which means manual reset. You have to go to the machine room and pull the switch.
Right.
That'll drop out everything on the elevator, and when everything comes back up, as long as this doesn't have a signal from the switch down here, from the pit switch, this will stay in a dormant position.
Okay.
Now, if you move the jumper to the B position, as soon as this switch goes into the dormant position, as soon as this switch, you remove liquid from the pit, and this switch goes to normal again, this will drop out automatically.
Oh, okay. Okay.
So, we're giving them that extra option, and it depends on the building conditions. Like I said, if it's like 10 cars, well, maybe they won't trip. Maybe you'll have a way to get to the machine room. You won't have to walk up 15 or 20 stories. But if it's one car, do you want to walk up 20 stories to reset it? No. So you're going to use the automatic instead of the manual reset. You'll let it reset automatically as soon as the liquid is removed from the pit, and that switch goes back to normal.
Now the wiring, the 4 wires that go from the power board up to the controller, are those considered travelers? Travel cables?
Good. Traveling cable is something that travels with the elevator,
Okay.
right? Remember we were looking at this?
Mhm.
And we said that as the car travels up and down, this coils up under the car and then uncoils as the car comes down.
Okay.
That's a traveling cable. What they have to do is they have to find, what did I use for that? Right?
Black.
Black.
Okay.
They have to find here hatch wire. This is
Okay.
hatch cable.
Hatch cable.
Now, all elevators have hatch cable. And the reason they do is because this hatch cable feeds your car buttons, right? Your up and down hall buttons, I'm sorry. your up and down hall buttons are fed by the hatch cable. In addition to the pit switch down here, and maybe you have position indicators at the bottom. In the lobby here, you have a PI. All of that stuff is a hatch cable. And that's just wiring laid into either pipe or ductwork that travels the length of the hatchway and ends up terminating at the controller.
So they might already have some that they
If
can
these
use.
things were installed according to code, code says you have to have 10% spare. So if you had 40 wires, and that's about average for an average hatchway, you should have 4 spares, 10%. And you should be able to use those 4 spares to do what we have to do. If you don't have spares, then you gotta find them. Or you get creative. Sometimes you can pick up power from some device that's already down here for your power. Now you only need 2 wires back to the machine room. Remember, 2 of the wires are going down for power, right? And 2 of the wires are coming back with the signal,
Turn the signal on it.
right?
Right.
So, if I can cheat and find my power here, then I only need 2 wires. And this is up to us as designers to design it in the most efficient way. Sometimes we'll look at a print and say, oh, we have pit power here. We can come right off the pit switch. We have the common for the other side of the power supply. Our power's here. Just look up to it. And we'll tell them to do that. We'll show them on the print how to do that. Then he only needs 2 wires to come back up to trip the controller device during the event. So depending on how we design it, will depend on how many actual hatch wires they need. We tell people 4 because that's the worst scenario.
Okay.
But it
But
could
you
be
might
2.
see the prints and go, oh, you only need 2.
Right.
And that means to run 2, but there might already be 2 available.
Spares.
So that saves a couple hours of
Oh, of course.
install,
If
right?
they can
You
pick
just-
up the 2 wires here, then this is a very simple install. And the reason it makes it simple is, first of all, this is a very simple board. And all we have to do is send the car to a specific landing, which is a very, in my business, in the engineering end, which is a very simple task in the engineering end to do. So even though you see like 5 relays on this board, it looks complicated, it's not. The only thing we will do with this board is, in the event of a fire emergency, we will shut this board off. We will not allow any of the system to work, because fire service takes precedent over any other operation except hospital emergency service and inspection. Inspection is a manual operation of the car. Hospital emergency service is just what the name implies. You're in a hospital, you're on emergency service, you probably got a passenger, you're not gonna let fire service take over. And we're not gonna let fire service take over this device either. We're gonna shut this device off. We are gonna let fire service take it over. We're not gonna override fire service with this device. Because from fire service, if I have sent the car here and I go on fire service, it says the car has to return. And in that case, we're gonna let the car do what it has to do, because we're not gonna be responsible for a fire that may injure or kill people. And that's part of the code too. Nothing can interfere with fire service except those 2 things I previously mentioned. So, bear in mind that this does meet that criteria.